Hello, and I guess it's good morning. Depends on when you watch this. We're doing the 2010 AB number 3 question. So let's go ahead and read the important information. So there's 700 people when the ride begins. So let me write that down. That says when T is 0, there are 700 people. Once it begins, the ride accepts passengers until it closes at 8. While there's a line, people move into the... Okay, so you gotta really think about what's going on here. There's a line, 700 people start, people continue to enter, but there's people that leave. So when it says people move onto the ride at the rate of 800 per hour, that actually is a rate of leaving the line. The graph shows the rate R of T of people arrive. So R of T is important to note. That's the rate of arrival. Let's continue reading this. T is measured in hours from the time the ride begins operation. So again, T is 0 at the start. How many people arrive at the ride is question A. And I'll do this over here. How many people arrive from 0 to 3? Well, we have the rate of arrivals R of T. So if we want to find out how many people arrive, if you integrate the rate of arrival, that tells you how many people have arrived. But how do we do this? We don't have the function, so we can't take the antiderivative, but we do have the graph. So that means we just find the net area to find the integral. Here's 3. So we need the area of this region here. How can we break this up? We could do 2 trapezoids, but I think what I'm going to do, let's see. I'm going to get crazy here. I'm going to do that triangle, and that triangle, and that rectangle, and then the big rectangle. So a little side work here. I'm gonna call this area 1. So area 1 is going to be 1/2 base times height. The base is going to be 2 hours. And the height goes from 1,000 to 1,200, so it's going to be 200 people. Plus, I'll call this 2. 2 is just base times height, so again, its base is 2, the height is 200. And I'll call this 3. The area of that is 1/2, the base is 1 hour, and the height goes from 8 to 12, that's going to be 400. Plus, and then I'll call this area 4. That's just a rectangle, the base is 3, and the height is 800. So you can leave your answer like that, that's perfectly fine. If you were to add all this up, we would get 3,200 people. But again, don't simplify. This is a calculator problem, so I guess it's not too risky, but you don't want to make a mistake. Okay, part B. Is the number of people on the ride increasing or decreasing between 2 and 3? So increasing, decreasing, you should immediately think of the justification for increasing, decreasing. That is when the derivative is positive, then it's increasing. Derivative negative, then it's decreasing. So the number of people in line waiting is what they're concerned about. Now, you don't have to do all this, but it'll probably be beneficial. We're going to define A of t, and that's going to be the number of people in line. And then, like any other accumulation problem, it's a start amount plus the people that arrive minus the people that leave. And we are told we start with 700 people. If you integrate the rate of arrival, and that is R of t, but we already have t is used, so we have to pick a different variable. We'll call it x, and you integrate the rate of leaving, but we are told right here the rate of people leaving is 800. Now we could have written that at the beginning. The rate of leaving or exiting is 800. It's a constant. You can give it a different function name. You can call it E of x for exiting, but it's 800 people per hour. Now, we need the derivative of this because that will tell us increasing or decreasing. The derivative of 700 is 0. And here, we're taking the derivative of an integral from 0 to t. Now, if you look here, t is our variable, so we want to take the derivative with respect to t. And the fundamental theorem says if you go from a constant to t, you just plug in t. So that t there just gets plugged in, and we get r of t minus. Now similarly, they're taking the derivative of the integral from a constant to t. I plug in t for x, but there is no x. So therefore, that's just 800. Now this should make sense. We have the rate of the people in line. Well, R of t is the rate of people entering. 800 is the rate of people leaving. So if you combine those, that's the rate of the number of people in line. So between 2 and 3. So if we look at the rate between 2 and 3, R of t, let's give it a nice color. It's going to be this line right here, the green. And you can see that R of t is always bigger than 800 between 2 and 3. So here's what we're going to say. Since R of t is greater than 800 for t between 2 and 3, was it? 2 and 3. We don't include the endpoints because it says between. Therefore, R of t minus 800 will always be positive, which is a prime of t. So if the derivative is always positive, thus, you like my fancy words, the number of people waiting in line is increasing. Bam. So we've covered B. Now another way to think of this, again, all of this up here technically is not necessary. The rate of people in line, you could just say it's the rate of arrival minus the rate of leaving. And logically, if the rate of people arriving is greater than the rate of people leaving, your line's gonna get longer. So logically, that makes sense also. But let's go to part C. You want the longest line, but that's another word for the maximum number of people in line. You know what? I'm going to pause here. I'm going to break this into 2 videos because I don't want my steak to overcook. So we will do C and D on a second video.